Thank you and welcome to this introduction to Spring Live. Now, you bought the course in Spring Live development, so let's do a more formal introduction to what we're going to do for the next good couple of hours from this time on. As I told you before, that I'm an assistant professor and I work in a Danish university. I've been a teacher since 2009. I developed a lot of web applications in my 20 years. Back-end, front-end, mostly back-end, but I have a good deal of experience in front-end development as well, which I'm going to teach you more about in this course. So what will we actually look at in this course? We will look at the framework of Spring in a very practical way. Now, I will give you an approach towards the MVC setup. We will use HTML, CSS and JavaScript, of course. We will use something called Timeleaf. It's a templating engine language, and if you're not familiar with that, don't worry, I will explain everything and how it works to you. We will of course build a web page, and I will give you some very good hints here and there from my experience. Since I was like 13 years old, I developed web applications. So from back then to now, I have a lot of things I could tell you, but I'm gonna stick to the most relevant things. So how will I teach? I believe that we need to do a straightforward and practical approach. I will not bore you with loads of theory, slideshows, shows for hours, multiple slideshows per video. Only the first 3 videos, the introduction and a few other things, as you will know in a few moments, will be me talking to you. Else it will be live code with you. So we will do things together. You will learn things up front, firsthand, by me. I will mostly just code and develop our web application and different projects, of course, use cases. It could be a practical approach towards a certain application type, let's say an administration system, which we're going to build at some point. We will work mostly and directly from our code, and I'll explain everything in a very down-to-earth way. Our very first steps before we start to code is to understand what is a framework and what is Spring. So after we establish that, we will start to code, and I will not show, well, I'm not gonna promise, but maybe a slideshow too, not that much, however, mostly coding, right? So let's begin, and my name is Daniel E. This is Spring Live. Hi. Welcome back. So we're going to talk about what is a framework, right? So in Spring, and Spring is a framework, it is a collection of functionality to make our life more easy. And you could say that it supplies you easy access to complex functionality like security, URL routing, MEC, database operations like object relational mapping, and many more, of course. The most important part is that a framework does supply with an architectural approach. So it's sort of things to understand. If you really want to understand what a framework is all about, you should just get started with it in a practical way, a hands-on approach. So for those that are very curious about different things it's all about, you could go and look up stuff like security, URL routing, MVC, and so on. The web model is all about how's a web page created. So a web page is all about knowing HTML, CSS, and JavaScript. These days there are two different approaches you can choose from. Either you do the REST API and you communicate with the service through JavaScript, or you create a web page in a traditional manner where you have probably an MVC setup. So in order to use a framework, you need to understand the following different things listed here: HTML and CSS, important building blocks for every web page. JavaScript is kind of important. It's not a necessary thing to understand or to know, but without that, it could be a bit stiff of a web page. We will look at that during the course. Spring, that's one of the frameworks you could use. And then of course, most frameworks come with a template engine language. So to start up with HTML CSS, that's really simple. Normally I would call HTML the skeleton of a building, and CSS is the color, the shape, the body, right? JavaScript is not like Java at all. It's a scripting language, first of all. It does not give you the typical approach of object orientation, however it does support it. JavaScript is for manipulating HTML and CSS, so you can get some dynamic features on your web page. We will also look at that during the course. Template engine language is a type of functionality implemented in most frameworks. It works with the data model. So typically in Spring you collect a lot of data from a database, you populate it in a list to a certain model, where the model is a normal class with getters and setters. How would you output that to an HTML format? Now that is the actual template in a language that does that for you. We will use something called Timeleaf, which is really easy to use. So when we get into it, you will get your hands dirty with Timeleaf, and we will pretty fast learn different techniques to output your data from your database to actual HTML the user can see. So we have one more slideshow to look at, and for now, I see you in the next video. Thank you. Hi, and welcome back. So let's talk about the very last thing before we get into the actual coding part and get our hands dirty. So what is Spring, right? Spring is an application framework. You should think about it as something you can use just to build an application. There is not any particular usage like web only, which is probably the biggest misconception there is about it. We will use it to build web applications, and it does support the MVC architecture, which is pretty good for us. As I also wrote, the Spring framework is basically just an application framework, right? And it does a lot of XML configuration, inversion of control, dependency injection. There are different ways you could configure your Spring framework to do the actual things we're going to do if you want to do it the manual way. And that could be to either you configure it manually with XML, which is a long way to go, or you could do it with Java itself, or you could do it with annotations, right? So we're going to use something called annotations. It's an @ sign that we do to identify what is a class used for, right? So when we get back into the actual coding, or when we will get into the coding part, I'm going to explain what is all this annotation stuff and get right into the part where we'll get the hand surgery, right? So what is Spring? If you really want to learn something more about what Spring is beneath the surface, you can go read this tutorial here. It's on Wikipedia. It's not something that I created. It's free to use. It gives you a pretty good insight of what is a framework and what is Spring framework. We're going to use something called Spring Boot, and it's actually a framework itself that supports a lot of configuration and setup that enable us to develop Spring applications faster without any of the mentioned before. Of course, we will have to use annotations. The core Spring framework will require you to do lots of configurations such as XML descriptors. And as I talked about before in the past slide, we will not do everything the manual way. We will use what the industry does, right? So if you're gonna get a good job with good pay, you need to know what Spring Boot is. There are many good articles online where you can learn about the different parts about Spring, why you should or should not use it, and there are many different kind of articles. We won't dive into all this in this course. We will focus on the actual hands-on getting stuff done with Spring Boot actually, right? And I will use IntelliJ. You could use any setup IDE if you want to use that. That's fine with me. Spring, you could utilize different architectures. However, you will use Spring Boot where the MVC is in place. It's called Modern View Controller. So in Spring, a model is the carrier and the joint between the database. The view is what the user sees, and the controller catches requests from users. All this will get a lot more clear when we get into the actual part of coding a first web application with Spring. This is a classical MVC illustration. You could see if you are a user, you use a controller. The controller manipulates a model, and the model updates the view. And the view is something that the user sees. Now, there are many different MVC models or illustrations you can go and look at if you go and just go and do a search on the internet, right? The best advice is for you, if you want to get a good start with the framework, don't think about too much the details. It will confuse you a bit, for some even more. Maybe you should just start, get some stuff done, and then when you are comfortable with the different codes and how the setup is, then maybe then you could think about what is beneath, what is behind all the things you're using. That's what I advise you to do. So in many frameworks, and of course in Spring, it does utilize the MVC setup, but many frameworks do implement it in a slight different way. Now, I could tell you something right now, that in Spring, we will have to focus on something called the service and the repository layers. They are both logical layers, but with each different responsibilities. For now, you should just be aware of these facts, and then eventually we will go through it all and I explain it in a very down-to-earth way to you, so you will of course understand it. So, the final slide. Let's begin with the actual coding. In the next video, I will create a new project from IntelliJ. I will generate it as empty as possible, only with the least possible dependencies we need to build our very first Spring web application. I'll see you in the next video. Hi and welcome back. So in this video we're going to look at what is a controller. So I open my IntelliJ IDE, and for you that don't have it installed yet, you should go to your browser and type install IntelliJ, then go for JetBrains, and then you can basically download either the community or the ultimate version, which is on a free trial. If you are a student, you can apply for a free student license, which you have to Google something like free student license and pick the first link here. And then you can just go down, how to apply now, the blue button, and then fill out the form. I'm a student, I'm a teacher. If you're a student, you can fill out your form and the other necessary informations. So I started my IntelliJ now, and this is just the blank startup screen. I have created no projects, have created no code. So we're going to try the Spring framework for the very first time now. Let's create a new project. So I'm gonna click create new project. We're gonna choose something called Spring Initializer. Now that's the thing, the part that assembles our Spring project for us from the default location of start spring.io. Now again, if you go to your browser and type in start spring.io, you get to a web page where you can generate your basic Spring Boot web project using Maven with Java. This is the current version 2.1.1. You can even add a group name, artifact name, and different dependencies, and then you can press generate a project. If you do that, you will get a zip compressed file that you can download and import to IntelliJ. Now, instead of doing this manually, IntelliJ have that feature implemented in their IDE. So again, Spring Initializer. I have this current version of Java 1.8. This shouldn't affect you if you have 1.7 or well, this is version 8, but if you had, let's say, version 9 or 10, well, it shouldn't affect the Spring project, Spring Initializer. This is tied to the web page, Spring.io, subdomain start. I'm going to press next. I've done nothing. I just pressed Spring Initializer. So now we have the possibility to set our group name, the artifact, the type of dependency manager we want to use, or build manager. There are different possibilities. You can choose a popular one called Maven. However, you could also choose something called Gradle. Now, we're going to focus on Maven in our videos. We will generate jar files. You could also choose var. However, we are not going to use the jar file or the var file and upload it anywhere. We're just generating it, so you are ready at some point in the future video to upload it to some cloud service or online or application server like Tomcat, for example. And the rest of the things, for now, just leave it as it is. I've done nothing so far, just click next. This is important. Now you have to choose the different dependencies for your project. Now I'm going to press web, and I'm going to check the web here. Do pay attention that I use Spring Boot version 2.1.1. I could choose to go to the newer version, however this is default for me. So if you want to follow along, I suggest you use the same version. Of course there are some differences to different kind of the Spring Boot project. So again, please choose the same version. Now this is a web project, so we're telling Spring Boot to generate a web project for us. Now we go to the template engines, and we talked about using something called time leaf. So I press and check the time leaf. Our selected dependency should be web and time leaf. When you've done that, click next. Now, this is a project name. Let's call our project name Udemy underscore first underscore project. I created a folder on my desktop called Udemy projects. I'm going to double click it, take the path, copy that path, and put it here under project locations. So this is where my project will be located, and this is my project name. You can of course choose whatever name and location you would like. However, for the duration of the whole course and future videos, I will use this folder and this project name for the very first project. Of course, we will generate a new project at some point during the videos if it's necessary. Right now, let's stick to this. So I'm gonna press finish. And now, IntelliJ will think and generate our project. So I'm gonna move it to the screen. This is how it looks. Now we can see down here that it's importing our dependencies, generating our project. And that could take a while depending on your internet speed. So I'll wait for that. Oh, it's done. So you have two folders under your project here. Now if you press project and let's say you are on packages, you will see it like this. If you are under project files, you will see it like that. So please choose the right view format here. So click down here on the arrow and choose project. If you already have this, just continue from here. External libraries is just a list of whatever external libraries you have. Just to briefly open it, you can see a lot of stuff is here. A lot of stuff. And we will not talk about that. It's mostly dependencies and stuff for our project. Let's open our Udemy project here. We have different folders. The ones that we're going to focus on is, first of all, this file here, which is our Maven dependency and build file. Let's double click it. You can see which dependencies I've included, the different versions, and what it should say. So we choose to use the template engine called TimeLeaf. So we are injecting our dependency from Spring Boot Starter TimeLeaf. We also chose the dependency of web. So we are injecting Spring Boot Starter Web. And the other one here is for test, and we will not use that in this video. The other things in Maven here, the build and the properties and whatever you see here is other things that is mostly related to Maven. For the duration of these videos, I'm going to focus on this group here called dependencies. And dependencies, which you can see is the start tag is here and the ending tag is here, just like HTML. So this is a dependency, this is a dependency, and this is also a dependency. Anytime, whenever you want to put a new dependency to your project, you can always just add one here, right? So this is beginning to become a long video, so let's wrap it up by creating our very first controller and starting it in a browser. So I'm going to go to source, I'm going to go to main, I'm going to go to Java, and this is our project name. I'm going to right click it, select new, and select package. The package name, I'm going to call it controller. Basically, you can call this folder whatever you would like. It's merely a way to create a structure in our project. Now, I'm going to create a video at some point where we will talk about the different structures you can choose. So right now I'm going to choose the one that I'm using, I think the best. On the controller, let's right click and create a new Java class. We will call it the home controller. Click OK. Now let's remove this comments field. So, as we talked about, there are different ways we can configure our Spring project. One is through some heavy duty XML configurations. We can do it through Java, or we can do it with annotations. Now, since annotations is really easy to use, I'm gonna use annotations. So I'm gonna write add controller, just like that. And we will import our Spring controller stereotype. So now we tell Spring that this class is actually a controller. And as we talked about, a controller is the class that intercepts the route that we access from our browser. So let's generate our very first route. Now let's go to a browser and let's assume that you write something like localhost and we access this port, for example. Then that would be the actual root web page. And to access the root web page, we need to write something like add get mapping, like that. So that's an annotation. Now get is for the HTTP protocol, which is the protocol that a browser uses to communicate with our web server that we can start in this program, which is also going to be the process that runs our web page. Mapping is the word. It's just a conventional name, right? So get mapping for whenever we want to request a resource, and slash is the root one. And whenever we hit that route, we're going to call a public string method. Let's just call it home for now. And let's return something as simple as, let's give it a good name, it's the index. Now, you probably wonder what happens now. If you run this right now, you will not get the expected result because we still need to create a view. And under resources and templates, I'm going to right click, new HTML file, and call it index. In this HTML, I'm going to generate a h1 tag and write, this is our very first web page with Spring, smiley face. And then I'm going to go to application properties and write server port equal to 6565. Now this is our server port we're going to use. This is just pre-configured right now in our application because our web server should be running on this port, because I have different web servers running using the default port, which is 8080, like this, right? So I'm just going to override that. You can do it like this. Pay attention to application properties. It is the place where you can configure many things for your application. Also where we're gonna put our database connection in a future video. So let me just close this Maven file down. The demo is called Palm. We have our home controller. We annotated our class with controller. We annotated our method called home with a get mapping annotation. Now I'm gonna press run right now. I'm gonna go to the web page and write 6565 localhost colon 6565, and voila, this is our first web page with Spring. Now in the next video I'm gonna go a bit more into the details of what we just did and what happened, because a lot of things happened right now for us, and a lot of magic happened. So until next time, I'll see you. Hi and welcome back. So in this video we're going to look at what did we just do in the previous video. Now, first of all, we created a new web application in our most favorite editor called IntelliJ, and then we tested it in our browser, just like you see here. So let's have a look at the application structure. Under source, we have our main, Java, and our actual name of the application, which we didn't really do anything to. We just kept the obvious names and kept the defaults. Now inside this we created our controller package, and we have our home controller saved in that package. This is just a Java class. Basically we can give it any name you would like to. It could be called something, well, if you want to call it Jumping Tiger, you can do that. It wouldn't necessarily give a good idea of what it was. So the home controller is just one controller. We can have as many controllers as we would like to in our project. Now, Spring needs to know that this class is a controller. So as we talked about in our introduction slides, that a controller controls whatever routes is being intercepted by our web application. And now when I say a route, take a look at this. Usually you go something like example.com and you press enter, or you go to something like example.com/about, or you can go to something like example.com/gallery, and so on. Now this is what we call the root route, or the lowest folder you can go to on your web application. So when you have this get mapping annotation, you're basically telling the Spring web application that the slash, which is essentially the same as saying this or that with a slash in the end. You can go and test that on any live web application. For example, Microsoft.com, with or without the slash, it will give you the same. So think about it. If you want to create a route called about, it's actually as simple as just writing about here, just like that. But for now, we're going to stick to this one route. So now, since we annotated this class as a controller, Spring understands that it needs to look in this class whenever it intercepts a route from the browser. And here it is. So this class contains the actual functionality that should be invoked whenever this route is entered in the browser. And you need a public, and string is because we're actually returning something called index. And index is actually coming from our resources folder under templates. There's something called index.html. By default, it just takes the name and say, well, if there's a file inside the templates folder called index, and pay attention to that, I didn't write .html, that's appended, so Spring knows, right? So it would automatically load this file. You can probably think that if we have like 50 or 100 different pages on our web application, this index would be among a lot of more HTML files, and we would then need a structure. And in future videos we will create a better structure, and I will of course explain you how to do it and what is going on in the background. You probably thought about, what is this static folder? Now, the static folder is for your assets, stuff like images and CSS documents, your JavaScript, and so on. Also, if you want to host some videos and stuff like that, you could put it into your static. However, I might recommend that if it could be put on something like YouTube or some other online streaming provider, it would probably be a better idea. But if your video is licensed or something that you own, and well, YouTube definitely not you own, then you could put it on your web hotel or web domain where you host your web application. Now, this demo application file is just, I'm gonna open everything here, where your program starts. This is also where your public static void main method is defined by Java default conventions. You need this method, and it will basically just say run our Spring application, and that's it. So this is our starting point. We don't need to use this file, we can just close it again. Primarily we're going to use our home controller, and we will add some different routes and create some more views. And also, the HTML file here is also our view. This is what the user will see whenever the user requests a route from a browser. So until next time, I see you again. Hi and welcome back. So in this video we will talk about what is a view in more details, and we will also look at how we can transfer data to a view from our controller. So in the last couple of videos we did create a view called index.html. So let's start talking about what this is. A view is basically a HTML file in Spring in this scenario. We can put any amount of HTML and CSS and JavaScript in it. So you've probably been working with HTML and CSS at some point or for some time already, and you probably tried to implement some design, images, create a layout with some colors and stuff like that. So all that is for the view, and then with JavaScript you can make it dynamic in a way. So in our view we only have one line of code. It's a h1 tag, which is short for heading 1. Basically the same as a heading that you can find in Word. So h1 is the largest, and h2 is the second largest, and so forth. Now in Spring we do transfer data from our controller to the view. So if you go back to our controller, that is right here, we call it home controller. We can then inside our method here, which is the method that returns our view. Now this is an area we haven't really talked about that much, so let's put a few more words on it now. Whenever this route from an HTTP GET request is being returned, we will invoke this method called home, and it will automatically return this string. So it is not just a string. By conventions, and this is behind the scenes, guys, behind the scenes Spring is taking care of all these things for us. So it is a string, yes, it's encapsulated in double quotations, so yes, it is a string, but Spring is converting it to a view. Well, now there's only one word here called index, so this word here, index, and that is index, is the same, and it's located in templates by default. So it will automatically try and fetch this and return it back. So whenever we go to a browser and type, as we did before, localhost, colon, and then in application properties, we can see our port is 6565. And we press enter. This is the file we will get back, which is the index file, which is also what this get mapping tells us, to return the index file. So if I want to share some data now from my backend, which is what the server will execute for us, our Java code, our controller, I could create inside our method a string. I could call it name, and inside here I could put my name, Daniel Ellebæk. There we go. In order for us to relay this string back to our controller, we need to pass this variable, string name variable, to a type of container that is automatically shared down to a view. Now this is again some magic behind the scenes, right? So at odd as might seem, we need to put something called model here, and let's just give it a name called model with a lowercase m. Now the object is called model. First of all, it's becoming red, so we need to import it. So I'm pressing Alt Enter, and there we go. We now got our import from the Spring Framework, UI, and model. This object here, first of all, let's just accept the name is probably a bit confusing when we're getting into the part working with models. This is also called model, right? Right now, just accept the fact that this class here is a carrier for our variables that will automatically be shared down to a view. This is happening because on the backend, on the server, on the web server, running on port 6565, right? It will automatically take this class and share it down to our index file before we return it to the browser. We only need to do one last thing, to call model and call the method called addAttribute. And first is we have to give it a name, so let's just call it my name, and the comma, the actual value, is the name. There we go. So what I'm saying is I have the argumental area here, and I know it seems weird, but think about it this way. Whenever we are accessing our route, the root route, our method is being called, and we inject down a model object which we need to add our attributes with a name and an actual object. It could be an object or just a variable, it doesn't really matter. In our case, it's just a variable, right? So then this method is being called, we create our string, we add our string to the model object, and then we return the index. And behind the scenes, guys, what happens is that this model is being shared down to our view called index in this case. So if I go back to the view now, and remember this name, my name, which is a variable name in a certain way that we can call and get a string out of, which is my name. So let's go back to the index page, and I'm gonna down here write a span tag, and I will say th text equal to, this is timeleaf syntax, okay? I'm saying I want with timeleaf to access some text, and inside the double quotations, that is the area we're gonna work with. I'm gonna write something as crazy as a $, 2, not 3, but 2, a start and an end, curly bracket, and then I'm gonna write my name. That is the variable, of course. Go back to controller. The variable is called my name, and it holds my name, which is Daniel Illebæk. So now we have an error here, right? We need to include the context area where this syntax can be read from. So I'm gonna press Alt Enter again. There we go. And get this line here. This is the context area where we can read this syntax from. So we know in the backend on how to handle it. So before this HTML page or the view is being handed back to the browser, this is being executed. So only thing missing is for me to restart my server. And then let's try and see it. Okay, everything seems smooth and running. So I'm gonna pull in my browser window and say localhost :6565, press enter. And this is our very first web page with Spring, and my name is in the bottom. So let's just right click and say view page source. And what we see here is a span tag, a self-enclosed span tag, so it has a starter and an ending part of the span tag. I'm gonna go back here. So what we see is actually the output of Timeleaf, and Timeleaf is our template engine language, which is going to work with whatever we put in our model, which is the carrier. So already now we can begin to think, well, can I then create a second variable? Let's just assume that I'm gonna divide my first and my last name into two variables called fname for first name and lname for last name. I'm gonna remove my last name and I'm gonna remove my first name, and then instead of name I'm gonna call it fname. And then instead of having just one attribute, I'm going to create a second attribute and call it lname. And the first attribute is called my name. It would be a good idea now to create different names. So I'm going to call it first underscore name. Now you can call this anything you like. So basically I'm just giving it different names right now, so you guys have an easier way to accept how things work right now. So I'm gonna restart this. Oops, we forgot something. We need to go back to our view, right? And now it's not called my name anymore. So I'm gonna remember to call first underscore name and last underscore name. And then we will restart our server. So I'm gonna go back to my browser now, just wait a few seconds, and there we go. So I'm gonna right click, view page source, and we see we have two span tags now. So we can verify that it works. We can see that we can easily just create a lot of variables, and this works the same way with strings and integers and so on. So in the next video, I'm gonna talk a bit more about how we can use Timeleaf to output whole objects of data. Okay, that's it for now. See you later. Hi, and welcome back. So in this video, we're going to look at what is a model more specifically, right? So, as I told you in the last video, we have to accept the fact that the name of the object we're using to carry data to our view is called model. But there is something called models, or just model in Spring MVC as well. If you are familiar with this MVC setup, you know what I'm talking about. Now, just to clarify, this object could have been named anything else. it is just named model. So what we're going to look at now is also called model. However, it has nothing to do with this. So I'm going to go back here to my project view and right click the highlighted path and create new package. Okay, and we're going to call that package for model. Inside that package, I'm going to right click, select new, and say I want a Java class. And now we have to decide which kind of data is that we want to model to our web application, right? So let's assume that what we want to model is a person object with a first name and a last name to carry forth the idea we already started with. My name, first name and last name. So I'm going to call this object for person. It's a good idea for you to think singular now, so you just write person. What I mean, not plural, so just person. If you write persons or people, it is okay. It is again just a name, but sometimes naming it correctly can be a big help to you later on. So we click OK, create the class. I delete the comments. Inside of this, I'm going to create something private string first underscore name. I'm going to create a private string last underscore name. And for now, that's going to be my two only properties that I create inside my person object. Now, some call these for properties, others call them variables or class variables. They're all the same. So we need to generate. So I right click, generate a constructor. First I'm gonna create an empty one. Now that is something for Spring. Spring needs a empty constructor. So you could probably ask why. Well, it's a part of the creational phase of how Spring initializes an object. You shouldn't worry too much about it right now. Just accept the fact that you need to have this empty constructor. And I'm gonna go and generate another constructor with both of my properties so we can initialize our class with first name and a last name. And then I'm gonna right click again and press generate, and now I'm gonna choose getter and setter. So we're gonna generate both getters and setters for our first and last name. That's it. Beautiful. This is just a standard object. So if we were to use this in normal Java console convention application ways, that's a long word, right? Then we would create a list. Let me just pretty fast sketch what I mean, like lists, person, and then we probably call it for persons equal to new array list, like this, right? But we're not going to do this in Spring, not on this level at least. This is just what I chose to create to show you that this is normally how we would use our object to carry data, the first and the last name. So we can now say persons.add, and we can add, these person objects and iterate through it with a for loop, or enhanced for loop, and whatever way we would like. In Spring, we're going to use this object in a similar way. Of course, there's going to be a lot of built-in features. So for now, let's just accept the fact that we will use the framework. As I also said, this is a very hands-on course. So we're done with our person class. I'm going to go back to our controller now. And let's see. What I want to do is to create an object in my controller. I want to populate that object with the first name and the last name, like the person object dictates I should, right? And then I want to send it through to my view using the model carrier class. So let's change this code. I'm gonna delete the 3 lines here because we don't need to initialize our 2 strings, and we only need 1 attribute. and you're gonna say, I need a new person object. I'm gonna call it Bob. Set it equal to new person. I use the constructor and say Daniel Ilibek, and then I'm gonna include my object by putting the marker, the cursor marker, on the top of the object. If you pay attention to the small line that is beneath, it means that we can actually, by pressing Alt Enter, as the blue pop-up says, include com example demo model person by pressing Alt Enter. So I'm gonna do that. Com example demo model person. Okay, com example demo model person. It's just the path. So, and Bob is the name, and Bob is going to be the carrier variable that I'm going to put in my model add attribute. And instead of the name last name, I'm just going to call the person. Now, this is again just any name you would like. You could write something fruitcake or candy cane. It's up to you. I wouldn't recommend it because naming is what makes other people, well, understand what you created, right? So I'm going to go back to time leaf now, because this is the time for us to actually output our data. So let's go back to time leaf and say, okay, I have these two time leaf output tags. I only return one object. Okay, what I mean with this is I haven't created a list of objects. This is just one object of the person, of the class person, that I call Bob, that I put in an attribute called person. And this person attribute I can output here. Now, before I only returned a string as a simple value, right? Well, it is a complex type, but it's just one value. Now I'm actually returning a real object called person that I created. So I have to call the object person by its attribute name, and then I have to use conventional rules by Spring, use the same name as I created my variable with inside my object. So let's go to our view. I'm gonna write person dot first underscore name, what I just said, and then I'm gonna write person dot last underscore name. So the convention is really easy. Make sure that you write the first name, your caller name, as your attribute name, which is person, and that object is populated with this variable, which is a person object. And inside our person object, we can see that our string variables are created like this, with the first underscore name and the last underscore name. You can write any name you would like. Just remember that you have to follow your conventions. So in our view, we do person dot first underscore name. So let's try and test this. So I'm gonna restart the server, start and rerun. I'm gonna pull in my browser window, and in a few seconds, there we go. So up and running, refresh the page, and I have exactly the same thing once again. And this is what we expected, because what we did was just to put our data in an object. We call it person. It's just a normal class with getters and setters. And by using name conventions, which we have to do in Spring, and by creating a new version of that, a new instance of that, and we're calling it Bob, then we can access our data from this attribute. We can name it anything we would like. I call the person, and that's the first caller name I use in time leaf, person dot, and then the conventional name call, first underscore name. If you follow these rules so far, you can just try and stop the video, create a new class, call it, for example, pets, and a pet name and a pet age for the two properties, and then in your home controller try and add a new attribute to our model and call it, for example, pet, and output that in the view. When you got so far, you are pretty far with Spring already, so you can create controllers, you can work with views, and you can work and create models to carry our data in an object to our view. So in the next video, I'm gonna talk about something totally new, and I'll see you in the next video. Bye. Hi and welcome back. So we need to talk about something called the repository and the service layer. So in this video I'm gonna show you a couple of slides. I know it's not my style, but I figured out that this might be the best way for us to approach the two different things called the repository and the service layer. So you have something called a controller, right? A controller is something that controls the routes. You usually call it the consumer layer. It also returns the view, showing the view, and it also calls the service. So if we look one tab down, we see something called service. Now the service is the actual business layer. So if you're familiar with MVC already, you might say, well, yeah, that's the model, right? And in Spring, unfortunately, it is called the service layer, which is also why I explained in the very first time when we introduced the course that every framework has its own way of using or implementing MVC. The service layer is our business layer in Spring. This is where the actual application code is stored. Now, when I say application code, I mean business logic. Stuff like you want to modulate something, you want to take a list of users and do something with those users, filter them, or just run through them all, make sure that they fulfill the requirements. You know, business logic, logic for your application. Now, service layer do have one more responsibility, and that is to call the actual repository. And the repository is called the persistence layer. The persistence layer is where you communicate with your database. So the call hierarchy should be controller, service, and repository. So first you call your controller through some route that you accessed in your browser. Then if you have nothing to do but just showing a view, which is a HTML page with no dynamic content and no database interaction or whatsoever, it's just static view, then of course you would stay on the controller. But if so, there's some sort of business logic going on here. It could be that the user posted some data from an HTML formula. Well, then that data would have to be sent to the service layer to be modulated or intercepted or sanitized or whatever you want to do. That is the service layer. Then let's assume that this data the user posted should be put into a database. Well, then you need to call the repository, which is where the data would be inserted with actual SQL sentences. This is also where your database connection is lying. This is where you could communicate with an actual database. So the next page, this one, shows a connection in a scenario where we have more than one controller, where we have more than one service, where we have more than one repository, and more than one database. So as you can see, our controllers can share service layers, our service layers can share repositories, and our repositories can share databases. Now, I didn't show that with an arrow in this particular example, but you could, of course, do any sort of connection. Now, you're probably wondering, now, you understand the controller layer, you understand the service layer, and you understand the repository layer, right? So what is all this repository and service? Because as I told you, I would do a very hands-on approach. So let's take the last slide here. Well, so what is the service and repository layer? Basically, it is a class. A service is just a class. So just a normal conventional class you create, and then you annotate it with something called service. Then Spring would know that this is a service layer. And the same story goes for the repository. It is still just a normal conventional class that you annotate with the repository annotation. Then Spring knows that this is a repository. Now, of course, there is a need to annotate service and repositories with the add service and add repository. When we get to the point where we will use something called auto-wired, yes, auto-wired, then you will see a connection to why it is important that we do the annotations. On a hands-on approach, or first-hand approach you can call it, doing it is the very first step. So I'm gonna show you in the next section. It's called section 3. We will create our first real Spring project. We will still not have any database, so we will leave out the data to keep it as simple as possible and focus on only Spring. So that would mean that we will use some static representation for our data. We will create a list, array list, something like that, and we will fill it with some, just some test data, so we can test our application. So in the next video, which is section 3, we will begin to look at a real Spring setup. I know you're eager to do all your database and communication, but I would like to make sure that you focus on the actual Spring part first, because a database isn't really a part of Spring, right? So let's take it step by step, very hands-on approach. We will do something together where you will see the same results as I will. Okay, so that's it for now. I'll see you in the next video. Bye. Hi, and welcome back. In this video, we're going to focus on creating a fully fledged web application with all the principles we learned so far. So we will start with creating a new project and then adding a controller. So let's create a new project. I will do the exact same steps as I did before. I'm gonna pick Spring Initializer. I do nothing else but that. Click Next. Then we have the possibility of naming our different things here, our group and artifacts. Just make sure that you have a Maven project, the packaging is Jar, and you're using the language of Java. The rest is, well, not that important for now. Click Next. Under dependencies, we choose Web, Template Engines, and Time Leaf. I'm gonna click Next. And then the project name. Let's call it First Web Application. I'm gonna print finish. Now our project is created now. So I'm gonna open it. There we go. I'm gonna go and create a new package under our COM example demo path. New package. I'm gonna call it controller. And inside the controller package, I'm gonna right click and choose Java class. I'm gonna call it main controller. Then I'm removing the comments, adding the controller annotation, and then I'm gonna create the root slash and it's going to be invoked by the public string index method. I'm going to return just index. Okay. Before we go on to the next video, let's just briefly go into the application properties and set the server.port to 6363. In the next video, we will look at how to create our model, and we will, from that, figure out what to do. Hi and welcome back. So in this video we're going to create our model. So we created our controller in the last video, so I'm going to go and right click here at the controller example demo, select new, package, I'm going to write model. In the model I'm going to right click on that, say new, Java class, and now's the time for us to create our model to carry our data. So this is a small application we're going to do with all the different layers of logic, business logic and persistence logic. So I think we should stick to something simple as listing some items. So I'm going to call it item. Very generic name, I know, but I guess it'll be okay for this little small demonstration project. In the model I'm going to create a private string and call it name. So every time item has a name, I'm going to create a private int and I'm going to call this price. So our price will always be a whole number, so it will never be anything with decimals. And that's it for now. So I'm going to go and generate our empty constructor for Spring, and then I'm going to generate a new constructor with both properties set, and then I'm going to create getters and setters for both. There we go. So this is going to be our model that will carry the data from us. Now in the next video we will look at something new, which is to create the repository layer. So I'll see you in the next video. Welcome back. So in this video I'm gonna create the repository, and the repository is the persistence layer. But as I also told you, this project is without a database. So the persistence layer will just be some static data we create in an array. I guess we'll use a array list with the item populated within. So I'm going to go and right click on our com example demo path and say new, package, and I'm going to call it repository. In the repository I'm going to right click and say new again and create a Java class, and I'm going to call it item repo. I'm going to remove the comments. So this item repository will contain our different data that we need to give back to the service layer. If you remember the slideshow from a prior section, we discussed what is the service layer and what is the repository layer. So since we do not have any database connection right now, we will have to create some methods inside of this repository. So I'm gonna go and write something like public and create a list of item, which is the return type, and I'm gonna call it fetch all items, just like that. And then I'm gonna include item, import the class of item, and then I'm gonna import the class of list. There you go. Okay. So fetch all items will return a list of
of items. So I'm going to create a list of items. I'm going to call it items and instantiate it by calling array list, just like this. So items, I will add an item, which will be a new item, just like this, something you've done before many times. And the very first is item name. I'm gonna call it a computer, and the price will be 100. Then I'm gonna copy paste this lines a couple of times, and I also have a laptop for the price of 150, and we will have a iPhone for the price of 125. And in the end, I'm just gonna return the items. Now, in a real scenario, when we get to a later part of this course, we will discuss the idea of having an actual database connection attached, and that will be created in the application properties here. So that will be in a later video, okay? So with this method now, we can go and annotate this as repository. There you go. So now this class is a repository, and it is basically ready to be used. One last thing I would like to do is to put a comment here and write, this is where the actual SQL communication would have been done. So just remember this is where our actual SQL communication would be done, our CRUD operations to the database. Okay, so in the next video I will create a service using our repository, and that service will be our actual business logic to our application. Okay, and welcome back again. We will look at how to create a service in this video. So I'm gonna right click our project name here, come example demo, choose new and package. Then I'm gonna write service. So we're almost done, right? So in this package, I'm gonna right click and say new class again. And I will call it item service. So I'm going to remove the comments first, and inside our item service I'm going to create our method called public, and remember that our method in the repository returned a list of items. Basically I kind of need to do the same, so let's just for now write this, return a list of items, and we will call it fetch all items, just the same name as the repository name. I'm gonna include items, I'm gonna include the list, there you go. So you're probably wondering, why is it the same, and why do I have duplicate names and duplicate return types if I already have it in my repository, right? So as we discussed before, the repository is for persistence work. So the actual database communication, working with SQL queries, sending data back and forth, but not doing any actual business logic, which is done in the service. So basically inside this service we need to call our repository and give it the finished data. So if we, for example, imagine that we have a login formula, and then we send the username, which is usually an email, and a password. Then inside the controller, intercepting those two values, we'll send them straight to the service. And the service could then modulate the email, check if, let's say, it's a real domain, or if it's within the given parameters to be approved, you know, name, convention, and so on. And of course, if the password is a real password, then we send that data after being sanitized, after being checked for this or that. Then we send the data forth to our repository to do the actual transaction between Spring application and the database. So Having that said, inside our fetch all items method in the service, I'm gonna have to call the repository. But before we can do that, we need to auto-wire our item repository to this. And auto-wiring is a very special thing in Spring, which in essence is all about dependency injection. And if you don't know what that is, I'm gonna create a video in the future about dependency injection and explain this thing in great detail. But for now, just accept the fact that when we are auto-wiring something, we are in a way importing our repository in our service layer. And now I can take this container and say fetch all items. And then I can basically just return it. And then I actually follow the rules of returning the correct return type. Now, this is a service, so I also need to annotate that as a service. It is really important that you remember to annotate your repository, because your repository can only be auto-wired in your service if the repository actually have the annotation of repository, okay? So please do yourself a favor and stop the video and rewind it a bit, watch what I said again a few times until you are ready to see the next video. I know it's a lot of information to take in right now. It will get a lot more clear in a few hours or the next day, or when you sleep on it, right? So this is it for now. I'm gonna create the view, and we will do the actual output of the data to our view, aka the HTML file. Hi and welcome back. So in this video we will look at outputting the data in our view. So I'm going to go back to the main controller, and yes, this is our route. The root route will invoke this method called index, and we need to create the index.html file in the templates folder. So I'm going to go to the templates folder, right click, say new, and choose HTML file. I'm going to call it index. In this file we will output the data that we get from the repository, okay? So before we do that, I'm going to go to the controller and say we need to have a model in the index argumental area. So I'm going to write model and call it model. And if you've forgotten what the model does, it basically ships the data directly down to the view, so we can access it with our template engine language called TimeLeaf. So I'm gonna go up in the main controller part here and say, remember what we did in the service? We auto-wired our repository. Guess what? In the main class controller, we will auto-wire the service. So I'm going to write item service and just give it a similar name. And now the easy part is just to write model, add my attribute. Let's call it items, and items will come from the service layer, item service called fetch all items, and that's it, we're done. So all the hard work we put in so far to creating our service layer, repository layer, to ship data back and forth between the different layers is so easy to call right now because we did our homework, right? So what I need now is to go to the view and remember my attribute name called items. So in the item view, I'm going to go here and say with TimeLeaf, I'm going to create a p tag, which is going to be repeated for each item there is in the repository list. Now I know there are 3 items, but who knows how many there are, right? So TimeLeaf th, please loop through each of my elements. The syntax goes that for each element we have, we put that element in a new variable. So I'm going to write item colon $, and 2 curly brackets, and it's called items. Remember, in the main controller, our attribute was called items. So items is the name here. So for each item we have, every single item will be shipped and put into this container here called item. And what would I like to do with that? Well, I would like to output that in the span tag. Time leaf, please give me the text inside the span tag from item.name. And then I'm gonna close it. And I also need the price. So I'm just gonna write price. And we're almost done. I just need to add the context to where Spring can find how to parse this syntax here. So I'm gonna have the mouse over here and press Alt Enter. There we go. And this is the context path we need, and that should be good to go. So I'm gonna give it a test run right now. We never ran our application before. Let's see what happens now. So our application is starting and it is running right now. So I'm gonna pull in a browser window, go back here and write localhost 6363, and there we go. We got our 3 items outputted to the screen, and I'm gonna right click, view page source, and we will see 3 p tags with 2 span tags each, encapsulated the right way with a computer, a laptop, and an iPhone. So, with all the things we've done so far, we created our model to hold our data, which is just a name and a price. We then created our repository, which would be the spot where we would do actual SQL communication for real if we had a database connection. But to keep it simple and to only do Spring stuff and to apply the right architectural way to do Spring web applications, we excluded the database for now and created a static lists of data in a list item, right? So in a real scenario, we would of course have more methods, for example, fetch one by ID or delete, update. Then we created our service, and in the service we said, well, the service needs to be able to communicate with the repository, so I auto-wire that in. And then we just called the repository method called fetch all items. And in the main controller, we then auto-wire the service, and basically from there we just add the model, give it the attribute, give it a name, and then call fetch all items, go to the view, and then more or less just output every single item in a normal loop with time leaf. So in the next video we will look at how to apply CSS and more HTML to our output from the loop in time leaf. And another way, we will look at the GUI, graphical user interface. So for now, I'll see you around.
Hi and welcome back. So in this video we're going to look at how we can apply CSS and GUI elements to our small but yet functional web application that we created with Spring. So inside our templates folder we have our index file, which is the only view we have to work with, which is also totally fine. So we need to add CSS, we need to add some more HTML to give it some basic building blocks. So how can we do that, right? So pay attention to the folder called static we have on the resources. Now static, that folder is for our assets, such as CSS files and JavaScript files, for example images, right? So let's assume that you want to create a new style sheet file, a new CSS file. If you're not too familiar with the term of what is CSS, I suggest you go and stop the video right now and go to the internet and search for something called w3schools.com, where you can find pretty good tutorials to introduce yourself to CSS and the whole world of how you apply GUI elements and colors to your web applications. Okay, so when you're comfortable with that, continue on this video and you can then venture forth, because now we are kind of opening the door to our web application, where we will begin to design and talk about how to implement visual elements to our HTML. Okay, so I'm gonna right click on the static folder now and say new and choose style sheet. So this is what we're gonna do. You could also, in theory, create a directory if you want your CSS to be in a CSS folder, and optional, you could also create right now. However, at some point when you are going to create more files, more CSS files, you're going to create more JavaScript files and add different types of files in the static folder, you want to organize your stuff in folders. But for now, we're gonna stick to the simple thing and just create the style sheet. So right click, new style sheet. I'm gonna call it main. So it's gonna be called main.css. It is an empty document, so I'm gonna put in a static wildcard rule, which is an asterisk, and we have two curly brackets here. So we have our CSS file, it's pretty empty, and we added our asterisk rule here. So I'm gonna zoom in a bit because CSS can be quite small to look at. It's very nifty and you have to get it right, else it doesn't work. Now we should be aware that CSS and HTML is not programming languages. It is just a way for the browser to interpret your wishes for the visible elements such as HTML, and CSS will then create the colors and shapes to your web application. Now I'm just going to write color red, a very simple rule. Basically it means that, well, I'm going to say it this way, say please Mr. CSS. That sounds really fun, right? Can you please color all my elements red? Okay, so this means everything. Okay, the wildcard rule is just everything. So I'm gonna try and go back to the index now, and let's include our CSS file to this index. So I'm gonna create something called a link tag. The rel attribute should say that this is a style sheet, so we know that this is a style sheet. And then the reference should be ... and a slash and main.css. Now, why do you think it's ... slash? Okay, think about it for a second or two. Yeah, I'm pretty sure you figured it out already. We're in the templates folder and you are in this file. So what you really want to do is this file should look one step back into the folder of resources and then access the main. But you probably think, but I didn't write static, right? Shouldn't you write static like this, static? And this is a special case. IntelliJ Spring Framework doesn't look at the static folder as a folder. It is just the resource, the assets folder, which will be dynamically shared. So in essence, forget about the static folder for now. Just think you need to go one back and then you can access whatever is inside by saying ... slash, and then you access it. So let's try and run this application. I expect my application to be, well, red in a way, right? So let's pull in the browser window. I'm gonna press enter now. There we go. And everything is red. Let's right click and say view page source. And we can see that we have our link. It points to the main CSS. I'm gonna click it. And we see the CSS we have attached to that file. Okay. So this is how you can apply GUI elements and GUI rules to your application. So you should try and experiment a bit now and say, how can I make this, but not the whole thing. I want to make the span tags green. And in the top, I'm going to put an H1 tag. I'm going to call this all our items. Remember, right? Our index file is an overview of all our items. So if I want the H1 tag to be red and I want my span tags to be blue. So let me just tell you once again. This text here should be green or blue. Okay, you choose one. It doesn't really matter. Let's stick to the idea. It should be blue. So the text should be blue. And then our H1 tag, all our item text, should be, let's pick a color, red. Okay, so how can we do that? If you want to do that yourself, please pause the video now. So I'm going to go in my main file and say I don't need this wildcard rule. I'm going to remove it. What I need is to say my H1 tag color should be red and my span tag color should be blue. This is another way of saying, please, Mr. CSS, all my H1 tags should be red, text-wise. And you also say, please, Mr. CSS, everything wrapped in the span tags, right? Every span tag, text should be blue. Of course, this is not the optimal way of creating your CSS rules, but just for testing purposes, for me to demonstrate how you can add CSS to your Spring application, this is probably enough. So I'm going to rerun the application. I'm going to pull in our trusty browser window and then wait for a second, update, and our H1 tag is red and the other text is blue. Okay? So this is how you can just add, just click on the static folder, right click, new, style sheet, give it a name, write your rules, CSS rules in it, go to your HTML file, or we call it the view, make the link tag, refer to it, make sure you have a // because you want to go one step out of the templates folder and access whatever is available, publicly available in the static folder. Remember, you don't have to mention the static folder. That is the special case, right? So in the next video, we will look at something new and interesting called fragments. What is fragments all about? Well, to give you a little teaser, fragments is all about that you create more HTML files that you use for a, well, smart combination, okay? Think about it this way. If we have 50 pages with the same menu in the top on all 50 pages, would it be a good idea to have that menu represented in HTML 50 times? What if we have to change a menu element? Then you have to make 50 changes, right? That is pretty bad. So I'm gonna show you a way how you can make just one change and you made it the change for all of your 50 pages. And that is called fragments. Also, usually you call it templating. And I know that the words templating and templates are widely used in many different places whenever you're gonna develop a web application. But don't worry, you will get it really fast. So the next video, fragments it is. See you guys. Hi and welcome back. In this video we're going to talk about how to use fragments. So fragments is a way to divide our HTML page into different smaller chunks, also called fragments. So in order to do that we need to create a new HTML file where all our other parts of a web page should be. So let's make something for a web page that we can divide into fragments. Usually when you have a web page, you have a menu in the top. So let's create the menu in the top. Let's create some links.
with HTML, and I'm just gonna call them empty links. So I will point the link reference to nothing. So this is the 3 links I have: link 1, link 2, and link number 3. So imagine that you have multiple web pages, let's say 50 different pages, right? Now I'm not talking about 50 different web locations like .com, .net, .org, different places, right? I'm talking about different pages, so you have many pages on your one web page, right? Or let's call it website. Then you would need to correct every single view you have or page every time you need to make a change to this menu that should be on every single page in your website. Okay, now in order to avoid that, you will divide this chunk into a fragment. So let's go into the templates folder and say new directory, and I'm gonna call it fragments just for the name convention. And in the fragment folder I'm gonna create a new HTML file, and I'm gonna call it top_menu. And in the top menu, I'm gonna go back and remove my content, these 3 links, go to my top menu HTML and delete everything in it and paste my menu. Now this top menu.html file should be the same for now. So I'll just close it and go back to my HTML. So the whole idea now is for us to put our menu back in the top. So if I just run the file, the project, I bring my trusty window back. This is our web page, okay? So what I want is in the top of our web page, I want our menu. So I'm gonna go back to the code again, and first of all I'm gonna do a div tag, and inside this div tag I'm gonna say timely please insert from the folder called fragments top_menu. Now that's it, okay? Nothing more than this. So I'm gonna run the project again, bring in my browser window, update, and there we go. We have 3 links, okay? I'm gonna right click and say view page source, and what you see is that I inserted the 3 links inside the div tag that I just created. So that's one way of doing it, okay? This is insertion. The other way is replacement. And what I would need to do is just say replace here instead of insert. Now replace would be almost the same as insert. It would just remove the div tag itself and only put in the 3 A tags from my top menu. So I'm gonna rerun the project, pull in my browser window, update the project. We see no difference. Let's look at the HTML, view page source, and there we go. Now the div tag around the 3 tags are gone. So that is how it works. That either it replaces the tag that, let's go back to the project code for a second. Either it replaces everything here, or it inserts, if I write insert here, and then insert in between. So it gives you the control to say, well, I'm just gonna include my HTML there, or I'm gonna insert it into an already created structure, okay? So that's it for this video. This is fragments. You should play around with it, create different fragments, try and put some more design elements into your view,
and play around with insert and replacement. Okay, so I'll see you in the next video. Bye bye. Hi and welcome back. So in this video we're going to look at something a bit different from what we're used to looking at. We will try to look at how we can implement Bootstrap to our project. So what is Bootstrap? Now I'm gonna pull in our trusty browser window and say I opened the Bootstrap, getbootstrap.com. So basically it says that Bootstrap is a way for you to build responsive mobile first projects on the web with the most popular front-end content library. Right. So it's basically a collection of HTML, CSS and JavaScript, and it actually offers you to get started pretty fast. So what we do is go to the introduction page and we scroll down a bit and see that there is a starter template here. So we can take this template here and basically copy paste it into our project. So before we do that, I need to explain to you what is going on, okay? If you scroll back to the top, it says something about quick start. Now I'm gonna give you a fast introduction and then you should stop the video and look through this page and figure out what is going on afterwards. Read the text first of all. So Bootstrap is, what I said, a big collection of CSS rules and JavaScript effects and rules. Essentially what you do is you're being asked to include an external CSS document called Bootstrap, and you're being asked to include jQuery, which is a JavaScript library for fast interacting with the HTML elements, CSS and assets on the web page. And then you're being asked to include something called popper.js, which is dependency for get Bootstrap. And then you're asked to include Bootstrap, another JavaScript file that essentially is just for different animations and stuff that you can get with get Bootstrap. On the top of that, if you copy paste all of this and replace it in our content file or view, you should be pretty much ready to go. So I'm gonna copy paste this and go back to our index page. Now remember, we would like to keep this here. This is our time leaf stuff. We would also like to keep this. So what I'm gonna do, and please do stop the video and look what I'm doing. I'm gonna put my cursor on the top, press enter a couple of times, paste in what I just copied, and you see that I have my big gap here. So now I can work with this. So I'm gonna go down and say, well, I need this here, my link to my own CSS file. So I'm gonna cut that and paste that in as the last CSS document. Now you probably wonder why the last, and why not any other place, like before here or there or in there, for example. It is basically because that CSS is a cascading rule set. So the last mentioned rule will be the favorite one, okay? So if I want to override rules in Bootstrap, I should do it in my own main CSS file. Okay. So I'm gonna scroll down again and I'm gonna take every part that's inside my body, this body tag and this body tag. This is what I created from our web application. I'm gonna cut that and put it in, well, just below the H1 tag. There we go. And
yes, this is important. Please pay attention to that this is getting red. The reasoning behind that is that IntelliJ knows that this is an HTML document. It says, well, you don't have the context, just like you have on the HTML tag here pointing to the context. You don't have that on this HTML tag, which is a part of all this. So I can go down here and delete my old HTML, okay? And I'm gonna then again put my cursor over here and press Alt Enter. And one more time. There you go. Then it came up in the top. Our context is back. And now everything seems to be fine. So I'm just gonna rerun my application and say, well, will this be it? Am I done? Ready to go? So I'm gonna pull in my trusty browser window and update my web page, and boom. Now you probably noticed that something changed. The links are a bit different, my text is a bit different. This is all a part of Bootstrap, okay? So now I have a basic template. So I'm gonna go back to my Bootstrap web page and say, well, now is a good time for you to pause the video and play around with this. Maybe even try and fragment some of this into different fragments. I suggest that you put, I would say, these files into a fragment, and you can probably call it the bottom or something. And maybe also the menu. Now you do have a menu here, so it's the top menu. Anyways, I'm gonna continue with this. So if we go down the menu and say it talks about layout here, let's press that. Now it talks about containers. They're the most basic layout elements in Bootstrap, and they are required when we want to use the grid system. And let's look at that. Now if we have something like this, it's an area which is bigger than the other one, right? So in order to have this type of design, we need to have a container. So what it really tells us to do is to create a div tag with a class of container, and inside that tag we need to put our content. So I'm gonna go back to the code again and say, well, that means that I'm gonna put a div tag here, give it a class of container, just like that, and put the very last wrapping div tag in the bottom of all our HTML, and that's it. Now I know it's beginning to look like that we have a lot of HTML, so we're going to zoom in a bit, and you will see that now we have our container tag, which is starting and ending down here on line 32, starting on line 17. In between we have our HTML, right? So that's the same thing. I'm just gonna restart the server so you can see what is going on right now. So this is it. I'm gonna update, and there we go. Now it seems like that we got some extra space on the left, which is a part of Bootstrap. I can right click and say inspect, just for the fun of it. And let's pull it back a bit. Let's press this here, select elements. Now I can hover, and if you pay attention to this, you can see that there is a somewhat skin color tone, maybe a tad orange to you, depending on how you look at it. That's actually because that stuff is centered right now. The container is centered in the area of our web browser. Our text in the container, which is the blue area, is actually left centered. Now, I hope that you did read up on HTML and CSS, because this is probably really hard to understand if you haven't. So feel free to stop the video and go and read about HTML and CSS before you continue. Okay, so what we're gonna do now is go back to the Bootstrap web page and say, okay, so you gave us a container. What about something different now. So I'm gonna scroll down and say, let's see what we have. Grid system. This is a really good thing for you to learn about. The grid system is something, and look at this. You can just copy paste this example and you get these 3 columns. So let me just do this. So I'm just gonna copy paste this, go back to my browser, sorry, my IntelliJ, and around here I'm gonna paste the HTML in and restart the server. So I'm gonna pull in my trusty browser window, there you go, and close this, update it, and there we go, we have our 3 columns. I hope you can see that the 3 columns are actually in the center of my browser. Now this is the really neat stuff. I'm gonna resize my browser window slowly. Please pay attention to what happens, okay? That's the first jump. And the second jump, okay, and the last jump. So our web page is right now adaptive and responsive at the same time. It might seem a bit weird to you because we haven't really put any effort into making it look good. So let's go back again and see that we have different possible grid options we can use, and we can even make different kind of grids, equal grids, and you can just copy paste that example if you want to play around with that. Or you can create columns, or different size of columns, that something is 2 over 3 wider, so they 1 of 3 and 1 of 3. You probably get the idea with this. You can create really nice designs. So what you probably think about now is, what about content? So you have different things you can choose from. You can choose headings and lists, and tables. You can create those, and forms and buttons, and every kind of really neat, interesting element, right? So I'm gonna go down here to components, and let's see what we want. We would like a form, okay? And we would like something like this, where you can put in our email address and our password, and we can press this checkbox, check me out, and submit. So I'm gonna go down here and say, oh, that's the code? How easy. Copy paste, back to IntelliJ, and in the bottom of all this, I'm gonna paste it in somewhere crazy and restart the server. So let's see, update the web page. There we go. I'm gonna zoom out a bit so I can see it. So here we have our text fields. We can check it and submit. So I'm pretty sure you get the idea of how easy it is. I'm gonna stress the fact right now, okay guys, that we are not focusing on beautiful stuff for our web page. This is just a functional introduction to how to implement Bootstrap, okay? So I'm just showing you how to do it. The actual design and making things look beautiful, that's for you, okay? So we could just go back and say, what about buttons, okay? We have different kind of buttons to choose from. So I'm just gonna say, oh, we have a lot of buttons here. I'm gonna copy paste every single one of them. Go back to my IntelliJ and say, let us have the buttons in the top. I'm gonna restart the server. There we go. Update. Now we have it. All our buttons. Let's see how beautiful they look, okay? So, my wish for you right now is that you play around with this. You do yourself a big favor and spend some time try and implement more Bootstrap design stuff and try to take maybe a course in Bootstrap. It's a bit longer than what I just told right now. And when you're ready, combine what you learned here, Spring stuff, Bootstrap. You're getting ready to take your first bigger web development assignment where you can implement design, functionality, JavaScript, HTML, CSS, backend stuff, communication with a database in a future video, right? In this course, of course. So that's it for now. I think it's a good idea to stop the video. It's becoming pretty long, around 15 minutes. So in the next video, we will begin a totally new chapter. We will do real SQL. We'll start to learn SQL and to use JDBC. Now, you should be able to do some SQL already, but if you cannot, don't worry too much about it. I will try and explain it in a very down-to-earth way so you will understand how to implement SQL with Spring. Okay, I see you guys. Bye bye. Hi and welcome back. So in this video we're going to look at how we can create our database and how to connect to it. So first of all, we need to host our database, and I found a free spot called gearhost.com. Now I'm already logged in, but as you can see, gearhost.com /databases is where it will take you when you click the link called databases. So I have currently no databases, so I'm gonna create one by clicking create database, and then we're gonna choose a free version of MySQL. Okay, so you get 5 megabyte, which is enough. We're gonna give our database a name. Let's call it Udemy DB, and we're gonna create an empty database. I'm gonna click the link. When that is done, we see this. This is our database name. This is our connection string. That's our username, and the password is right here. Now I'm gonna show you the password I have for this particular database. It's randomly generated. So what you see here, you cannot use. You have to create your own. Go through the creational process on gearhost.com, and then you can use. So let's continue by connecting to the database. I'm gonna pull up my trusty MySQL Workbench program. Now this is another program. You could use any MySQL client that you would like. If you prefer PHP-MyAdmin on a local host installation, you can do that. Or if you prefer SQL Pro, you can use that as well. But I'm going to use MySQL Workbench. So I'm going to create a new connection. I'm going to give it a name, Udemy DB. And then we need to copy our connection string, the username, and then store the password in our vault. So I'm going to copy the connection string. Go back, take the username. Now a really easy thing is to remember that the database name and the username is always the same when you use gearhost. So I'm going to go back, paste in the username, I'll copy the password, click store in the vault, paste it in, click OK, and now let's test the connection. Okay, success. So I'm going to click OK and OK again, and then I'm going to click the actual connection tab here. So let's create our database. It takes a while because gearhost is not the fastest host you can find. It's also free, so you should expect 2 to 4, maybe 5 seconds delay for every request you make to the database. Okay, so let's create it. So I'm going to open my database, right click, create table, and Now you probably think, what should we call this table? Did we create a model? Now let's look at our code again. We created a model called item, and the item had two properties. One was called name and the second price. So let's go back again to MySQL Workbench, and we have to obey to this name convention. So if the model is named item, we should name it item as well. It doesn't matter if you're using small letters for the database name. As you can see here, we have a large I in the model name. Well, that's fine. So I'm going to click here. We need an ID, which we're going to use for the primary key, not null, and auto increment. And then we need to have our name. Let's assume that the maximum amount of characters is 75. And then we need a price. And yeah, name and a price. Okay, so the price, we can store that as either a varchar, or we could use an integer, depending on which kind of operations we're going to do with it. Now, if we go look back in our model, we did choose integer, so we should by convention choose an integer. So I'm going to choose int, and then I'm going to click apply, and apply again, and finish. I'm gonna again open, and there's an item table and columns, ID, name, and price. So I'm gonna go in the row, the table, and I will add the first item just to have some data. I'm gonna call a laptop, and the price is 100. Okay. So I'm going to click apply, and you will see the SQL sentence. If you wish to copy paste this, or just to learn SQL by using MySQL Workbench, you can do it this way. I'm going to click apply, and everything is okay. I'm going to click finish, and then I'm going to go back to my code. The next step is now to create the actual connection, and then we have to do a few new annotations to our model here. Then we have to change our repository, because right now we are using a static representation of our table, which is just, you know, an item list with 3 instances of our model class. So in the next video we will look at how we can connect to the database using normal JDBC connector strings. Hi and welcome back. So in this video we're going to look at how to connect to the database that we just created in GearHost, and we created a table using MySQL Workbench. So with our somewhat static web application we have right here, we need to connect to it. So if we look back on the application properties files that I briefly talked about in some prior videos, this is where we can connect to a database. So what we really need to do is to say Spring, the data source, and we have to put a driver class name equal to a path called com mysql cj jdbc dot driver. There we go. And then we need to say Spring data source URL equal to, and this is where our connection string should be. So I'm gonna finish this line at the final stage. Spring data source again dot username, that's for the username, and Spring data source dot password, and that is for the password. So I'm gonna go back to this window here. I'm gonna pull it to the side. Now we need our URL and the username. Now I'm gonna put in the username first and then the password, and the URL is a bit special, so I'm gonna go here and type JDBC MySQL colon and then paste in our connection string and then the actual port number to communicate through, slash, and then the database name. Now this is a typical JDBC MySQL connection string where you say JDBC uses MySQL connector, and this is the actual path online to where the database is located. This is where the port, which port we should use to communicate with the database, and this is the actual database name. Now it seems like that I have a slight spelling issue here, so I'm going to remove the capital D and make it lowercase. There we go. Now this becomes red, and this is because that I didn't add my dependencies in my pom.xml file for the Maven dependency manager. And what we need is a dependency to manage our MySQL. So I'm gonna go here in the bottom of our dependencies, highlighted here, there you go, and I'm gonna paste in the MySQL connector Java, and we also need the JDBC. There we go. So these two dependencies we do need for our database connection to work. So I'm gonna go down here and look. It says Maven projects needs to be imported. If you get this pop-up, do enable auto import. So I'm gonna do that. So if you didn't click enable auto import and this is not your first project and it doesn't work for you, then go to File, Settings. Now if you're on a Mac, it's called IntelliJ, and then Preferences. And go in here and you can go and type Maven in the search field, and if you pick the very first Maven importing, import Maven projects automatically should be checked. So mine is checked, everything is okay. If yours is not, then please check it. So I'm gonna go back to the application properties file and voila. Oh, it's semicolon in the end. I'm gonna move that. There we go. Old habits. And then we're good to go. So this is our database connection. This is the only thing we need to do in our Spring project. Next step would be to annotate our model. And now it becomes a bit special. So I'm going to annotate it as entity. And I'm going to go in here and create a new private int called ID, which I'm going to annotate ID. Now, first of all, let's import these missing dependencies. So add Spring Boot style GPA to the class path. Wait for a second or two. There we go. And it's the same thing for the ID. Add Java persistence. There we go. Now, in order for you to have the minimum amount of annotations in your code, you, as a bare minimum, you need the entity annotation to say that this table is, well, this is a class, right? So say this class is a table that should be mapped as an entity to the database. Now it's already enabled to be a part of the database, and as a other minimum you need to have your primary key, which is the ID, annotated with the ID. Now there are many different other annotations you can use, such as one-to-many, many-to-many, one-to-one relationships, And you can also have column annotations where you can override the name convention and say, well, I'm not gonna rename my variable here or the property, but I'm gonna force it through the entity, through the actual connection. Of course, that requires a bit more time, but nothing to be afraid of. We're just gonna stick to this, our model, getters and setters, the entity and the ID. So at this point, it should be a good idea to rerun the project and see if you get any errors. You never know. So I'm rerunning the project, and it seems like that everything is running as it should be. We can always just scroll a bit to the right and see here. It doesn't say anything special or errors, so that's really good. Okay, so now we are connected to the database, and the next step would be to go into the repository here and start to do the actual SQL sentences. That should be a part of the actual transaction between the web application and the database server. So in the next video we will look at how we can show the data from the database using timeleaf, and actually it's gonna be a pretty long video because we need to create the repository layer. We have to implement a new method. No, we can use this actually. So we can keep the service layer. We need to recreate our repository layer. We need to we only need to recreate the repository layer. So let's see how long it gets. Okay, see you guys in the Hi and welcome back. So in this video we're going to use the database and fetch every single item from the database and show it in our view. Now, since we did such good steps to prepare this before we actually create our database, we only need to work more or less in our repository from now on. At least until we create more methods, then we need to apply more methods almost everywhere. But just for fetching all items that we have here, the statical way, we can just create our database communication here. So what I'm gonna do is to remove all this. We don't need it anymore. And what you should do is to either comment everything out like this, or you should delete it. I'm gonna delete it. And what I'm gonna do is say we need a string variable, let's call it SQL, just like that. Now we have to select all from item. Didn't we call our database for item or table? Now you think, the easy part is look at the model, right? It's called item, and that is also the table name, and we always select data from the table. So if you are not sure, you can just look at this model and say, well, it's named item. Of course, if you had more than one model and you were uncertain which to choose data from, you could always just double click it and watch out if it had the entity and the ID annotation as a bare minimum. So this is our SQL sentence I'm gonna fire off to the database. The next thing we need to have is something called a row mapper. Now I'm gonna write the code first, and the row mapper should go to item. And we can basically just call it row mapper and set it equal to a new bean property row mapper. There we go. And that should be tied to the item class. And whoops, there we go. I'm gonna include this alt enter import class, and what we would like to do is to just delete this return statement. So what is this? Row mapper is our, what can we call it? Object to work with that can contain an instance of the request that we get from a database. Maybe the name itself gives us out a bit. Row mapper, so you map a lot of rows of data. So that's a lot of rows you have in the table, right? And each row have a select amount of columns, okay? So you say this row mapper should be tied to this model, so it automatically knows that data will look like whatever this model looks like. That's pretty nice, right? And then we instantiate with the new bean property row mapper, which is the actual class. So we can always just hold down Control and hover the mouse, and we can click it, for example, and you can see all the code here is just a class. And you can see that it implements row mapper. So using the loose coupling principle, you can see that we use the type or the super class or super interface, whatever you call this instance, as our type, and then we instantiate the type with the actual instance of the class. That is why we use row mapper here to code to the abstract part. And the bean property row mapper do need to know again which type it is. The last thing we need to do is say I want to return my data. But before we can do that, we need to import and use our JDBC template, and this is something we haven't discussed before. So I'm just gonna go up here and write auto-wired, and we know what auto-wired is. That is all about dependency injection and version control. So we're gonna go in there, say JDBC template. Now please pay attention to the actual URL, org Spring Framework JDBC core. Okay, I'm just gonna click it now, and I'm gonna call it template. This will work because we have our dependency in order. You can always go and look back into the POM file and see, do we have our JDBC stuff? Do we have our MySQL connector? We do, right? So that's really good. So I'm going to go back to the repository again and say what we would like to do is to use the JDBC template, which is kind of an upgraded way just to use the normal JDBC connector stuff. So the template version is a bit more easy to use. It's like just an upgraded version for you to use to communicate with the database. If you want to know more about the JDBC template, you could of course always hold down the control key and press the actual class and then go read the code. And you can see that I got a lot of methods implemented to communicate with the database and so on and so on. It's maybe a bit advanced for you, so what I suggest is go and read about what is a JDBC template. But this is the most normal object to use to communicate with our database through JDBC. So what I need to do is say I'm going to return template, and the template will execute a query. And you see you got loads of overloading methods here, right? Query, 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 a lot of them, right? So we're just gonna pick one of them and put in our SQL sentence and the row, and the row mapper, the actual variable, right? There we go. I'm gonna remove the white space and we're done. Okay, so what we did is create a string, say select everything from the database. I'm creating a container for my data as interface type, tying it together to my model, and creating a real instance of the object that can work with the database and do actual leverage and carriage of the data in a model of data. And then we call the SQL sentence with query from the template, JDBC template, and say this is where to store the data and then return it. So that should be it. So why did I know that this is list item at return time? You probably wonder. You can always still go and try and say, what if I do like this? You can see that it says list T. So it does return a list of whatever type that we created. Now, since it's a type of item, I of course have the same type as item here and there, and this is why I can just return the instance of it. So let's go and take a quick look in the service here. So we return list and return item, same. In the controller, we call it, we populate our model, attribute, items. So I think it's time to rerun the project. Let's see if it works. So I'm gonna go here to my trusty browser and to a web application, and I'm gonna press, before I press enter, pay attention to this down here is our static data representation. So I'm gonna press enter now, and we got our laptop. And let's open MySQL Workbench just one more time. You see, we have a laptop and a laptop. I'm gonna manually go into the database and the table and say we also have a teddy bear, and it costs 10. I'm gonna apply again, and the data is saved. So when I go back to the web application now and press update, teddy bear will appear, and there we go. So now we know that our database connection works. So what we did, create the connection strings, create the SQL communication code, import the JDBC template, and we already did every other step. So in the next video we will do a bit more code, a bit more work. We need to find a way to insert data to the table, which is also really easy. So I'll see you in the next video. Hi and welcome back. So in this video we're going to look at how we can insert data to our table. So where to begin, right? First of all, I think our index page is becoming a bit messy to look at. Okay, let's look at it just for a second. It has a lot of graphics and Bootstrap elements we tested, and we do have a all our items view on the front page, but I think we should have a new route, a new page, and we should call it create or insert or something like that. So where you would like to start when to create a new route is basically up to you. Some people like to go into the actual templates and say new file and then call it create. Well, we can do that. So I'm gonna create a new HTML file, which is a view. Then I'm gonna create a h1 tag saying, actually, let's use our Bootstrap template. So I'm gonna go back here and take the first part here. Please do stop the video and look what I copy. So I'm gonna copy this first part in here and go back and say I would like this HTML as well. So the first part of the container and h1 tag saying create new item, and then I would like there we go, the button stuff here. So I'm gonna go back again and insert this to end everything. So I have my ending HTML tag, my ending head tag, start and end body tag. I have started and ended my container, and now I need a formula to where that I can insert my item name and my item price that I'm going to create. So if I remember correctly, we did create a formula. Yes, we did. So I'm gonna copy paste this HTML formula here we have on our index page, go back to the create page again and paste it in. So let's have a look at this. Now it says example label blah 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 blah. Let's delete the label just for simplicity. And it says input type email. That should just be text. Class, form control, ID. Now all of this is for Bootstrap. We can also delete this here, area described by. And the placeholder should be please enter a new item name. And the last part here, the small, is a tag that creates small text. And let's just remove that as well for simplicity. We'll go one step down and see we have another input field. I'm going to delete the label once again. And this is not a password, it is still text. Form control, and we should delete the IDs, by the way, because they are not used in this particular case. And the placeholder should be please enter a price. And we don't need the checkbox, so I'm going to remove this. And we have a button, submit. Okay, so we need to put something called an action and a method. The method should be post because we are inserting data. And the action should be /create. That is our route we're going to create in our controller. So I'm going to change the button to an... No, let's keep the button for now, it's fine. So I think this looks quite okay. Now, please do stop the video now if you need to take it a step back. I'm gonna scroll up and show you what I have here. And please stop the video and look. And now I'm gonna scroll down and you can see the last parts, okay? So, I'm gonna continue now. I'm gonna go to my main controller. And I'm going to create a new post mapping. I'm going to call it create. I'm going to import my dependency for post mapping, import class. Then I'm going to go and say public string create. There we go. Now it is up to us if we wish to name the method the same as the route. I usually do that, but not always. Now what we need to do is the data that we sent from the create HTML page is from the input fields. And we didn't give the input fields a name attribute, so we should do that by conventions. And say the name of this input field should be name, and the name attribute for this input field should be price. And this is because that in our model we did name it name and price, so we should stay to the same convention wise and name this name and price the exact same way here and there. If we do that, I can say model attribute item, which is a way for Spring to automatically create a new instance of the model class called item and populate it with the data that we get from create page. And I just included, by the way, the com example demo model item, so we can use the class in our main controller. Now we can't really do much more right now because we haven't decided upon what should we do when we get this data from the create page. Now I could say that we're going to return to the index page, so I'm going to say redirect, and a colon, and then a /, which is this / here it maps to. So I'm just saying, please go back to this route, and it will show the index page. So when I create a new user, I will return to the index page. Next step I'm going to do is to go into the repository now. And I'm going to create a public method. I'm going to call it, let's say it returns nothing, and call it add item, just like that. And then I'm going to say it will be argumented with an instance of the object that we want to create. And let's again create the string variable like this, and it's gonna be insert into item ID, name, price, values, question mark, question mark, question mark. This is because the JDBC template do support prepared statements as default, so that's really good. Now, if you don't know what prepared statement is a way to improve security and make sure that we sanitize our data and remove illegal characters. I suggest you go and stop the video and read about prepared statements if you are uncertain about this name. So the next step would be to say template, and then we're gonna call the update and SQL. So basically update is going to call the database and execute this SQL sentence. And what we need to do more is to add our, pay attention to the 3 question marks. The first is an ID, the second name, and the third is a price. So I'm gonna say i.get. We don't have something called get ID. And if I remember correctly, in our model, we did add our primary key, okay? But we did not generate getters and setters like we see we did not. So I'm just gonna go and say generate getters and setters and put the ID there. We have it. And I'm gonna delete this old constructor and create a new constructor with all 3 properties, and gonna go back to the repository again and say .getID. Second question mark here should be the name, so i.getName, and then i.getPrice. There we go. That's it, and we're done. So create the SQL sentence, insert into whatever, blah blah blah, question marks for prepared statements, for security, call the template, execute the SQL statement, and we get the 3 different values that we got sent through the object, item I, and basically that's it. So in our service, I'm gonna go down and do a new method. Gonna call it public and void, and we're gonna call it add item. There you go. And we have to supply the item as the argument, and then let's just say return, no sorry, just item repo, add item, and I. Okay, so maybe it seems like double work. If we go back to the repository, it says something like we're already doing the actual work there, but in the service we're just calling the repository layer. Please remember and go back to the video where I explain repository and service layer again if you are confused about these steps. So I'm going to go to the main controller and say what I need to do here is to go and say item service, add item, item, and we're done. So that's really easy. Now, what we do not have is on the index page, we should have a link that points to our creation. So how can we do that? Well, we did create our fragments, right? So I'm going to go to the top menu and say we have some links here. I'm gonna use this one and say /create, and it's gonna be create new item. The other two links for now I'm just gonna leave. So let's restart the project. I'm gonna open my trusty browser window, update, create new item, I'm gonna click the link, and we get an error. And what do you think we miss? Think about it for a second. It says request method get not supported to this route. Now this should be pretty straightforward for you right now and say, oh yeah, I'm gonna go back to my controller and say, oh, what I'm doing is I'm requesting a route in my controller by using get. But I have no get mapping that maps to create. So let's create that. So just get mapping create. It's a public string show create page. There we go. And let's just return and create. And that's it. Okay. As long as your different routes, if they have the same name, and as long as they have different mapping types, it doesn't matter. Then they are different, okay? Get and post are not the same, so you can have create and create like that. I'm gonna restart the project again. So when I press enter now, this should work. But I'm just gonna go back and update for you to see everything. Gonna click the link. There we go, create new item. And then I'm gonna type something like we need a harvester and the price is 5,000. I'm gonna submit this. Let's see what happens. Okay, so it works. We create our harvester for 5,000. I can go back and create a new item. It should be called car for 500. 1,000 is a really expensive car. Submit. There we go. So, in the next video, we will look at how we can delete data. And so far we are a really good way, and you are really lucky that you came this far. And if you are with me so far and understand everything I said, then it's really good. So I'll see you in the next video. Hi and welcome back. So in this video we're going to look at how we can delete data from our table. So it's quite easy actually. Let's go back to the index page and scroll down a bit. So at this part we will see our index, and we are outputting all our items, right? But we need a link. So when we click a link that says, for example, delete, then we will send the appropriate information to a method in a controller or route that will call the service and the repository layer and then delete the actual row of data in the table. So remember, back in the model, we did create the ID here, which is going to be the holder, the carrier for the primary key. It is automatically filled out when we use Spring Framework, and we annotated our model with entity. So if I go back here and say in the very end, I'm going to create a link tag, and timeleaf will then output for us the path. So I'm gonna create a add here, and the add sign is for routing in TimeLeaf. And I'm gonna say delete is gonna be the appropriate path, and in the end of that I need to add, and I'm gonna use the plus for the concatenation, the $sign, and to calculate the item.id, and that's it. Okay, and then the th text should be something like, actually we're gonna write it ourselves, delete. Okay, and to make it a bit more fun, I'm gonna give it a color here in a very bad way with the style attribute, color red. So let's talk about this for a second. What I do is I say TimeLeaf, please create the reference and make it a path with the add sign. Now you could in theory also use a $sign, but the documentation says use the add sign. And then I'm gonna put in the first part here, encapsulated in single quotations, because it works just like a string, okay? And then I'm gonna concatenate it to the actual primary key, just like we do like this. I output that name or that price. So when I click the link, it should say delete / and then a number. Let's try and run the project for a second now and just watch what will happen here. So I'm gonna update the page and I get 4 delete links. If I go and say right click, view page source, and scroll down a bit, we can see that it does point to delete /1, /2, 3, and 4. That's the primary keys. In the table, I can go and say, there you go, click rows, limit 1000, and you see 1, 2, 3, and 4. That's the primary IDs, or the primary key IDs for the 4 rows of data we have. So when I click one of these, I need to create the route called delete that should receive a path variable, and collect the path variable, save it, and pull it through to the service, and then the repository, and then we're done. So let's do that. I'm gonna go back to the controller now and say we need to create this get mapping called /delete/ and we have an ID path variable. I'm gonna create the method called public string delete, and then I'm gonna pull down the path variable by using the path variable annotation and say it's called ID. Yes, I'm gonna map it to an integer. So I'm gonna say just like that. Then I'm gonna go here to my delete method. What should happen when I delete it? Let's just reiterate and return to the index page. So I'm gonna do that and copy paste that. Okay, so we haven't really created the method yet to delete the data. So we need to go back into the repository and create a public void delete item method, which should take an integer and call ID as the argumental variable. And then we will create a string SQL just like before, delete from item where ID equal to question mark, remember the prepared statements. And just like add item, I will call the template update SQL sentence and say ID, and that's it. The reason I don't have to do an actual getter and setter here, just the getter, is because I have the actual value in a raw format. So the ID will be put there when I execute my SQL sentence through the template. Then I'm going to go to the service and add the method public void delete item, an ID. I'm gonna call the item repository delete item ID, and then I'm gonna go back to the controller, and right here I'm just gonna say item service dot delete item ID, and we're done. Okay, a few words now before we test the code. I know that in my repository I'm using void as a return type. The best way is of course to return something that we can check with an if statement, or try catch, or something that, you know, so we can return something to verify did we actually delete it, or did we actually insert or something. In many cases, what you would like to do when you insert a new row to the database, you would like to return the newly created row's ID, so the primary key's ID. It's an auto-incremental number, so you could do that already now by just doing a select statement afterwards and selecting the last inserted user and then returning that data. But in this example, I'm not gonna do it. This is just for simplicity to show you how to do the CRUD, create, read, update, delete. So I'm gonna rerun the project, go back to my trusty browser window, and click update now. Then let's say that this card is too expensive, so I'm gonna press the delete link here. Okay, delete. And there we go, it's gone. Let's look in the MySQL workbench. I'm gonna select all the rows, and there we go, the car is done. So this is how we do deletion with Spring. You probably guess now that the only thing we need to do is update, and it is kind of the same as add item. The SQL sentence is a bit different, so in the next video we will look at update. Hi and welcome back. So in this video we will look at how we can update an item. So there is quite a few steps in update itself, so I'm gonna start off pretty fast and say that what we need to do is go into the index here, and just like we created a link for delete, we need to create a link for update. So I'm going to paste that in and type update. I'm going to change the route to update. So we will request a get mapping route update with an item ID, and with that we need to collect one item from the database, and then we need to load the data into a form field, and then we need to edit the data from the form field, and then we need to send the data back in a post mapping route fetched by the controller, and then we have to go all the way down and save that item to the table. So it is the most steps involved creating the update functionality. So let's begin. We need a way to collect one item. We can go back to the repository and start there. I think that would be the appropriate way to do it. So let's stick to now. We have the link update, the repository. We will create a method called public, and it should be return one item, and then find item by ID and say int ID, and then we should have something like a string with a SQL sentence saying select all from item where ID equals to question mark, and then we should have a row mapper object to item if I can spell it. There we go. And then we should instantiate that with a new bean property row mapper tied to the item.class class. And then we basically just do a return template query for object. That's just one single object. SQL row mapper and then the ID, right? So basically what we do is we create the SQL sentence, make sure it's prepared. We have a row mapper just like we have in the fetch all, and then we execute our SQL, make sure to tell which object to map the object to from the database, the row mapper, and then the ID to fetch the single row from. So that's it from the item repository. But we also need a way to save and update our item. So let's create that at the same point. I'm gonna create a public void update item I as the argument, because we will put back the new item that should be updated, and we'll do that through a SQL sentence called update item set name equal to question mark, price equal to question mark, where ID equal to question mark. So that's a lot of question marks, right? Then I'm gonna call template and say update, and I will need to execute the SQL statement, fetch the get name with the first question mark. Second question mark is to get the price, and the last is to get the ID. Okay. If you ever wondered why I said it's because I created an instance of our model and call I just up in the update item here in the argumental area. And that's it for the update item. So I'm gonna go back to the service now and say I need to implement our find item by ID. It's an ID. I'm simply gonna call the repository layer just like that. And I also have to create a public void and then call it update item. I do a lot of misspelling today, right? And item I need to call my item repository and say update item I, and that's it. So it's really easy just to create the repository and the service layers, because now we can focus on the rest of the job, is to go into the controller and say we need to create the route called update that can take a path variable just like you see here. So in my controller I'm gonna go and create a get mapping. I'm gonna call it update slash ID just like before. I'm gonna create the method called public string update, fetch down the path variable, calling path variable, saying it's named, whoops, there you go, ID, and map it to ID. And then what we're gonna do is to send back a model view. So we need to add model and say add attribute, and call it item. And then we need to call our service layer and say we need to find, there we go, find item by ID. We're gonna find by ID. And I have an error here. Let's see what it says. Oh yeah. I did a slight typo in my repository and service. It's telling me that I'm not returning anything, and of course I forgot that. So in the find item by ID, I'm returning an item. In my service layer, find, I'm returning nothing. I should return item. There we go. Then in our main controller, the error disappears, and let's see, I'm then gonna say return. I'm gonna create the update view. So this view HTML file we need to create now. So in the templates folder, I'm gonna right click, say new HTML file, and call it update. So basically we can take the create page, copy everything, go to the update page, delete everything, paste in the copied stuff, and our HTML formula here needs to be changed a bit. Also, we should say update item because we're on the update page, and the action should be update. Let's just say update now because it's a new route. Okay. Oh, just wait a second. We have get mapping update, but we don't have post mapping update, and that we could do. So let's go back and just call update again, because now we are using a post. And item name convention is there, it's really good. What we need to do is to say timeLeaf, put in the values of the data I sent you from the object called item, and name please. Same for the price. And one thing we need now. What do you think that is? That is correct, right? We need to add a hidden input field to send our primary key ID forth. Because if we do not supply JDBC that communicates with the MySQL database with the same primary ID that we used, then it will just create a new row. But since we created our service layer here and we call the method called find and update, we don't really have the luxury to miss anything out. So what I'm telling you is that you should always supply every single row of data that you can when you are inserting or updating, because you need the primary key to identify the row that you want to update. So in my update, I'm gonna create my input type of hidden. I'm not gonna show that. Give it the name of ID and make sure that we output the ID here. Okay, so that's it really. So when we click this button here called update item, we will send all the data to the update route with the post mapping method. And we don't need the placeholders, by the way. So I'm gonna remove those. So when we send this to the update route using the post, then, well, we need to create it. So post mapping / create public string, and now, did I say create? I of course meant update. we should give it a different name because we have a method called update. We cannot duplicate our methods like that. So I'm gonna call it update now. And what I'm gonna do is to say, because we have the name conventions, I'm gonna say model attribute item, and then I'm gonna go in and say item service, whoops, there we go, please update my item and redirect me to the index page. So let's see, we have an error in our service, and I did spot this, but I think we should just wait till now to look at it and see what is going on. So can you spot the error? We changed the return type to item, right? It was void originally, so I need to supply the return statement. So it's really important that you also learn to debug your own code by just thinking about it, looking at it in a very down-to-earth, hands-on way. Of course, you can start all sort of debugging techniques and this and that, but that's also require time. If you can find the errors manually, you are in a really good state, okay? So I think it's about time to test and see whether this works or not. So I hope I did no typos. I'm gonna go back to the web application and press update. And I have my update sentences and the routes are correct. Let's try and update the laptop, give it a new name and a new price. Then I press update. Okay, so far so good. It loads my data into the form field, so I'm gonna call this laptop premium. And the price is now $125. So I'm gonna press update item. And look, it updated my item. So let's take one step back now and say, what did I really do? Well, when you update something, you need to first of all create some sort of a link or a button. I used the A anchor tag, which is always get mapping requests. So I created a route here, called it update, and I sent forth a primary key. Well, that's just the primary key for this item I'm looping through, and then I click it. When I click it, I go to the controller and I look for the get mapping update of, there we go, and the ID. Then I pull down the path variable and I supply a model through the argumental editor. And then I add the attribute. Say item, give it just a basic name, and then I call the item service and let us find the one that I'm trying to update. And then return the views update. Now the update view is an HTML file here, and on this file I'm just outputting the ID, the name and the price that I'm going to update. Okay? And when I'm done editing the text fields, I press the button called update item, which is a post mapping route to update. So in my controller I look for post mapping route update, it's here. And because I use the name conventions given in my model by always saying ID, name and price to different fields, whenever I have an attribute, I should say name equal to name in this case, and name equal to price. Just like this and this and this. Okay guys. So then I call the service layer and I update my item. So let's go down to the service layer and say update item, supply the item as an object, and then I call the repository. Okay. And the repository do update the item through SQL. So we have been taking a long walk now together, and we reached a certain point where we can create a web page, communicate with the database, do raw SQL sentences, do different multiple views. You can do all the CRUD, create, read, update, delete. You can even do prepared statements, which is a really good thing. It's a part of security, so that's an extra that I added to this video, so you also can do some security measures now. And then you can create something called fragments, how to divide your web pages into different fragments, and you can do Bootstrap, and you can apply GUI elements, and you are able to communicate with the database. So nothing much left. So in the next couple of videos I will talk about a brand new topic, so hang on and I'll see you in the next video. Hi and welcome back. So in this video we will look at something brand new again. It's called JPA, Java Persistence API. So let's put the dots down and the ifs and the whens and say, so far we did everything manually, okay? We created our own SQL sentences, we did all the work, we created a real repository with real SQL, which is also totally okay, because if you want and you require that control, where you can go in and fiddle with every single little thing, then SQL and JDBC template is probably the way for you to go. But there is a simpler way you can do all of this. They did do something called JPA, and it is just pure magic, okay? So what you really experience is that in your repository like this, you will have nothing. You just have an empty repository. So what I'm going to do is I'm going to go in and create a new file in my repository, and then I'm going to slowly show you how you can convert all of your code to using JPA. I'm not going to delete anything from this project. I'm just going to leave my repository as it is right now, but I'm going to create a new one. When you are creating a JPA repository, you are implementing something called the JPA repository. So let's look at that. The JPA repository is an interface that requires a type and an ID as to work. The type is of course item. So the repository will work with the item type of objects of the model, and the ID is for identification of the primary key. So when you implement this interface called JPA repository, you will get a lot of methods: delete and find and flush and get one and save all. And you also get methods from the CRUD repository and paging and sorting and query by example executor. So the JPA is the top, or you can probably say the most lowest one, because it does inherit from all the other interfaces. Okay, so you're probably wondering what is going to happen right now. Okay, so to make it all a lot more easy for you to understand, I'm gonna do all the work first and then we can talk about it. So in my repository I'm gonna create a new interface. So I'm gonna pick Java class but change the kind to interface, and we will then call our interface for something as fancy as item repo, and then we're gonna call it JPA, so we know that this is JPA. Okay, I'm gonna remove my comments. There you go. And then I'm gonna extend down the JPA repository, and I need to give the type of item and the primary key or identifier IDs is saved as integers. So integer, there we go. I'm gonna import my item class, and there we go. So now what should we do inside of our interface? And yes, nothing. So I'm just gonna do this and say we're done. And you think no, that cannot be, Daniel, right? You need to implement some abstract definitions of your method. I do not, because what I did is I extended this repository and we just saw on the web page, and I can show you again that the JPA repository do give us a lot of methods. So we do have a lot of methods already in our repository. So what you need to do now is to annotate this as a repository, and then we could go to a service and say, how did we use our repository in our service normally? We auto-wired it. Oh yeah. So if I'm gonna use the other repository now in my service, I could basically just replace this and say item repo JPA and give it this name, call it item repo JPA. I can also just remove the last JPA there to keep the name here. Now the next step would be to use different methods names. So fetch all items. Let's just go all the way back here and say we're gonna call the repo, and what we did before was just to put a dot, and whoa, we have all the different methods here, delete, and we didn't do any of those. I used the item JPA repository. Let's look again. Empty, right? It's pure magic. What really happens is Spring in the background, and the engine of Spring, it generates all the different implementation code from this part here. You know, it just generates it for us, so it's really just cheating. It's auto-generated. It works really good, by the way. So I'm gonna go in and say find all. Adding an item is not called add, it's called save. So I'm gonna put in S, save, and the I, sorry. So I'm saving. Saving is the same as adding. Delete, delete item, delete by ID, there we go, ID. And then find item by ID, return item. What could that be called? What about get one? So get one is the appropriate name. It also takes an integer as the argumental area, so just there you go. And update is a little special, it's also called save. If you remember, I told you about that I kind of prepared you in a way, a sneaky way I would say, that if you didn't supply the ID in the update here, you would insert a new instead of updating it. Well, actually, that is the case only when you're using JPA, because you're using the save method for both adding and updating an item. So when you are calling the save method, make sure that your object of item is populated with an actual ID. Else save will just create a new row. That is how save works. So if you do not give it an ID in the object, which you do not here in the add item, right? It will create a new one. So we're done. That's it. Let's go test our application and see if I did any typos as usual. So I'm gonna bring in my trusty browser window, which is having a lot of tabs now. I'm gonna update my application and see everything looks good, right? I'm gonna create a new item. I'm gonna call it test item with a price of 1, 2, 3. I'm gonna create this. Now I'm using JPA right now. Create test item. I'm gonna update my test item to be test item 2 and 1, 2, 3, 4, 5, 6 in price. Okay, nice. And then I'm gonna delete it. Boom. Okay, that's it. So you probably wonder, wow, this is really nice. So what you did is all of this or all of this, right? Doing the manual repository yourself, you get all the dirty work in your hands, you get all the control down to the single letter, or would you like JPA to handle different stuff for you in the background? Let's look at it again. No code implemented, lots of code here. Also this is a class, by the way, and this is just an interface, and that is what you do. So I think that's it for this video. We converted our JDBC to JPA, Java Persistence API, and basically everything just works as a miracle, right? So please do stop the video and go and watch everything again. I'm gonna make sure to give you the right URL so you can visit the JPA repository documentation and look at how it works. So I'll see you in the future. Okay, bye bye. Hi, and welcome to this very last video in this course. I hope you learned something new during this course. I hope that you now have a better idea about Spring, how to get started with it, how to do stuff with it, and how to do an actual web application. So what is next? Well, in a life of a web developer, you always have a next step. You have to start somewhere, right? So if this course was your very first course in web application development, or maybe your first Spring course in web application development, well, your next step could be something as interesting as security, maybe even Hibernate, and of course practice, practice, and practice. Now, I might add in the future videos that cover Hibernate or security, but the most important thing you could do is to practice. If you really put your mind to it, you can in a few months become a master developer with Spring, maybe taking a few more courses on Udemy, maybe doing some research, parallel research. Do whatever it takes to get the job with Spring. There's a lot of good money for you to earn developing good, steady Spring web applications. So, as the very last time, my name is Daniel E, and it's been a joy to be your instructor for this course in Spring Live. I'll see you out there, maybe in another new course. Okay. Have a nice day. Bye bye.